Okay, we're going to kick it right off. We're just going to dive in to algebraic expressions and the order of operations. So first of all, let's talk about what the heck even is an algebraic expression. Okay, so let's define that first. And an algebraic expression is an expression. And remember, expression means no equal sign. That's an equation that contains a variable, right? A variable is a letter that's representing a number. I don't care what variable you use unless it indicates to you in the problem there's a particular variable, but it really does not matter in the long run what variable it is. So when it says to write an algebraic expression for each phrase, so look at example A1. Okay, if we were going to write something that meant the sum of a number and 7, okay, we get to pick whatever letter we want to represent a number. I'm just going to use X. I thought for a long time about that. Okay, so the sum means add of a number and 7. So that would just be X plus 7, right? So sometimes it's easier, instead of saying a number, just make up a number. What would be the sum of 50 and 7? 50 plus 7. So what would be the sum of X and 7? X plus 7. Okay, so you just get to pick whatever letter you would like to use. Okay, what about the difference of a number and 10? Okay, the difference, what does difference suggest? Subtraction. So the difference of a number and 10, X minus 10, right? What's the difference of 50 and 10? 50 minus 10 is 40. Okay, look at, oh, really quick. Is this the same as if I'd said 10 minus X? No, that would be the difference of 10 and a number. This says a number, so that goes first, and 10. When you are dividing and subtracting, the order is important. Okay, look at A3. The product of a number and 9. What suggests product, or what does product suggest? What does that mean? Product is the answer to a multiplication problem. So the product of a number and 9 would be 9 times the number. Okay, so you can write it as 9x or 9 times x, okay, either way. What if I asked you to write an expression that meant the number of days in W weeks? And you're like, what? Okay, well, think about it. What if I asked you for the number of days in 3 weeks? What would that be? 7 times 3. What about the number of days in 10 weeks? 7 times 10. So what about the number of days in W weeks? 7 times W. Okay, does that make sense? Okay, twice a number P. Okay, you have P number of ponies, and now you get to have twice as many ponies. Okay, there's a couple different ways. I would write this as 2 times the number of ponies, right? Or 2 times P. But if you wrote it as, well, that's the number of ponies plus the number of ponies again, that would also be correct. Okay, and then half of a number X. So we have X number of dollars, and I get to take half of it. So we're cutting it in half. How would you write that? Okay, well, you could write it as 1/2 times X, or you could write it as X being divided by 2, right? What's another way? X over 2, or 0.5, right? If you want to get real fancy, 0.5 is the decimal for a half. So all of those mean half the number X, right? If we have $10, 1/2 times 10 is 5. 10 divided by 2 is 5. 10 over 2 is 5. 0.5 times 10, spoiler alert, is 5. Okay? So it's important when you're reading through these word phrases to look for keywords like sum, difference, product, quotient, right, is division. That's an important one. Let's go ahead and write that up here in case we forget it. Quotient, okay, is when you're dividing okay? So those keywords are what you want to listen for or look for to clue you in as to what the expression operation should be. Okay, now let's talk about evaluating, okay? To evaluate an expression for a given number, we're going to switch colors. We're going to plug the number in and work the expression out. Okay, we're plugging in the number and we're working it out. And when we do that, we are always, 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 forever and ever, going to use PEMDAS. Okay, PEMDAS stands for, who knows what the P is? Shout it out at your computer. Okay, parentheses. Okay, and I'm even going to write and other grouping symbols, right? Like brackets, braces, that kind of stuff, right? We're getting up there in math, so it could be beyond just regular parentheses. Okay, then the next step is always exponents, which we're not dealing with today, but we're going to write it out there anyway because that's the next step. Then multiplication and division. Okay, so here is an important part. Multiplication and division are the same level, right? Parentheses first, exponent second, multiply and divide third, because you multiply and divide left to right. Okay, it does not matter if you're going to, which one comes first. Sorry, I got distracted. It doesn't matter, or it's not always multiply before divide. It's whichever comes first in the problem, okay, or in the expression. And it's the same thing for addition and subtraction. Okay, they are the same level. You do them whatever comes first, reading your expression from left to right. Okay, so parentheses and other grouping symbols, then exponents, then multiply or divide left to right, then add or subtract left to right. So we're going to go ahead on the back of this page. You are going to do a few examples, or we're going to do them together. Okay, and every single time, you don't have to ask me. From this point forward, we will forever and ever be using PEMDAS every single time. Okay, every time we're using PEMDAS. So look at B1. It says we're evaluating. Okay, I don't think there's directions written on there, but that's what we're doing. Here, we can write it up here. The directions would be evaluate 15 minus y if y is 9. So all this is saying is we're going to plug in wherever we see a y. It's telling us y is the same thing as 9. So we're going to plug that in here. 15 minus 9 would be 6. That's for real. That's it. Okay, letter B2. 3C for C is 12. So wherever there's a C, I'm going to put a 12. So 3 groups of C, 3 groups of 12 would be 36. Look at B3. 2n plus 5 minus n for n is 7. Okay, so wherever there's an n, I'm going to put a 7. So 2 times 7 plus 5 minus 7. Okay, so let's think about PEMDAS. Are there parentheses? No. Are there exponents? No. Is there multiplication or division left to right? So let's start here, and we're going to stop when we see multiplication or division. Dun, 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 stop. There's multiplication right there. So 2 times 7 is 14. Okay, so is there any more multiplication or division? Absolutely not. So we're going to move on to the last step, which is addition and subtraction left to right. So 14 plus 5 is 19. And then 19 minus 7 is 12. So why don't you go ahead and do B4 on your own. Okay, pause the video, work it out, Okay, show your steps and then unpause it, and we'll double check it as when you're done. Okay, you should have your work written out, and your answer should be 14. So 3 times 6 minus 4. We're going to multiply first. That's 18. 18 minus 4 is 14. And that's my final answer. So pause, or do B5, then pause, and let's come back. Okay, so on this one, you should have done 10 divided by 5 plus 3 times 5. Okay, so let's look at it. Are there parentheses? No. Are there exponents? No. Is there multiplication or division? Yes. So let's do that left to right. The first thing that I see is 10 divided by 5, which is 2. Okay. Is there any other multiplication or division? Now there's 3 times 5, which is 15. 2 plus 15 is 17. Okay, let's look at B6. We're going to plug in a 2 every time we see the letter N, because it's telling us, hey, N means 2. So 6 times 2 plus 8. So are there parentheses? Yes, there are. 2 plus 8 is 10. And then 6 times 10 is 60. And we're done. Okay, so why don't you go ahead and do 7, do B7, pause it, and then come back and we'll check your answer. Okay, what you should have got is 72. If you didn't get 72, okay, cross out what you did, try again, okay, and then come back and I'll show you, if you can't figure it out, I'll show you how to get 72. So 6 times 8 plus y, and it's telling me, hey, y is 4. So inside my parentheses, 8 plus 4 is 12. 6 times 12 is 72. Okay, I know that because I am pretty good with my times tables, but if you weren't sure, you could come over here. Okay, 6 times 2 is 12. 6 times 1 is 6. Plus 1 is 7. So let's come and do number 8. Okay, this one is all letters. So the first thing we have to do is plug in, okay, the variable values. So y plus n times x. Well, y is 4, and then n is 6, and x is 2. So are there parentheses? No. Are there exponents? No. Is there multiplication or division? Yes, and it's 6 plus 2, or 6 times 2, excuse me. Okay, which is 12. 4 plus 12 is 16. And last but not least, number 9. Okay, so why don't you again pause it, come back when you have your answer, and then we'll double check it. Okay, for number 9, I'm gonna do a little thing to kind of separate it. So it's 4 plus 2 times x, which is 2, plus 14 divided by y, which is 7. Okay, so there's a lot happening here. So are there parentheses? No. Are there exponents? No. So I'm going to go through left to right and look for multiplication or division. So 4 plus 2 times 2 is the first one that I see. So that's 4 plus 2 times 2 is 4, plus 14 divided by 7. So I'm still on the multiplication and division step, right? Left to right, there's still division. So I'm going to do that next.